Hi guys, for today's lesson we're going to be dealing with equations for linear lines still, but we're going to be dealing with the point gradient formula. So it's a bit of a harder sort of application when you're dealing with straight lines. Okay, so what do I mean by the point gradient formula? It's a formula that gives the equation of a straight line given the gradient and 1 point on the line. So the idea is if you know the gradient and a point for your line, that is enough information to be able to figure out what the equation is. And the way that we figure the equation out is by putting our information, our m and our point, into this formula here. So our y1 has to change to this value here, our m changes to the gradient that we should know, and the x1 changes to to this number right here. You'll notice that in your equation you've got this y here and this x here. They won't change, they'll stay put, because typically equations for linear lines do show a y and an x in the answer. So that's what's going to stay put. Okay, so let's practice this formula. So find the equation of the straight line that passes through this point and is parallel to y equals 4x minus 1. And we want to have our answer in gradient intercept form. Okay, so with this information, because they've given you a point and they've given you that it's parallel to this, so therefore you need to understand that you know the gradient, it's the same as this gradient, and you know a point on your line. So you know the point, you know the gradient, so you can use the point gradient formula. Okay, so we've got that m is equal to 4 and our x1 and y1 are equal to 5 and negative 3. So that's all you need for the formula. So using the formula, rewrite the formula. Our y1 changes to negative 3. So we're going to get a double negative happening here because we're taking away y1. Our m is 4, so our m changes to a 4 outside the brackets, which is multiplying the brackets. And our x1 is a positive 5, so that just 5 comes down. Make sure you're remembering to bring your minuses down. Okay, now you have to deal with this line here. It's all about expanding these brackets now and getting y by itself because we want it in gradient intercept form. Okay, so 4 times x makes 4x. And 4 times negative 5 gives us negative 20. And the double negative here makes y plus 3 over here. Now we want to try and get y by itself because that is the gradient intercept form that we're after. So we're going to minus 3 from both sides. And we get the equation y equals 4x minus 23. That is the equation that we're after. The line that is represented by this equation is parallel to this line and it goes through this point. So we're getting the correct answers. Okay, question 2. Find the equation of the line that passes through this point and this point in general form. So that means we want 0 on one side in our final answer. So we know that it goes through these 2 points. Now the strategy is that you can find the gradient using the formula for gradient, y2 minus y1 over x2 minus x1. So we can use these points to figure out what the gradient is, and then you use the gradient and one of these points. You can pick either one. You can use the gradient and one of these points with the point gradient formula to figure out your equation for the line, and then you've got to convert that into general form. So let's go through that process. So we've got to figure out what our gradient is for the gradient intercept formula. So we're going to use the 2 points that we've been given, and it comes out as a gradient of minus 12 over 7. That's as simple as it gets. We want to deal with improper fractions typically. And now that we've got our gradient, we've already been given a point. You can pick either of these. We put it into the the point gradient formula. So I've decided to pick y1 as my 5. I'm going to be using this point here, so I don't have to worry about this point for the formula. So my y1 changes to this 5 here, and my x1 changes to negative 3. So we're going to take away negative 3, so double negative makes a plus 3 inside there. Okay, so we've got y minus 5 on the left-hand side, and now we got to expand the brackets with our gradient of negative 12 over 7. Okay, so when we're expanding these brackets with this fraction at the front, it's a little bit annoying, but you should be able to deal fine. So negative 12 over 7 times x, the x is going to multiply by the top number, and this 7 is not going to change. So you get negative 12x over 7. And then we've got negative 12 over 7 times positive 3, which gives us negative 36 over 7. You can just do the 3 times the top number to give you negative 36 over 7. And now we've got this line to work with. We don't want to deal with these denominators. So to get rid of a denominator of 7, we're going to multiply by 7. We have to do that to every single term. So y times 7 is 7y. 5 times 7 is 35. These 7s cancel and these 7s cancel as well. So leaving you with minus 12x minus 36. Okay, this is our equation, but we want it in general form. We want to get 0 on one side. So the easiest way to do this is to move the minus 12x and move the minus 36 by plussing them over to the other side. Okay, and we get 12 lots of x. We like to put our x's first, then our y's second, and then our like terms, minus 35 and plus 36, that gives us plus 1. So we get this is our final equation in general form. Okay, hope this helps you with the questions. Good luck.